Yeah, now we'll go for some of the examples on this particular topic called as an interference, as we have discussed the different scenarios in the interference. So in this particular example, there are the two light rays. One is an ACO light ray falling on a reflecting surface here. So light ray is reflecting from the O and reaching to the point P. And there is another light ray here which is traveling from the B to P. So these two light rays are interfering at this particular point, and he is asking to find out the value of the theta to obtain the constructive interference pattern. So remember one particular point in this particular question. Here there is an reflected light ray. Don't forget that particular point. Due to the reflection, there will be a phase difference of 180 degrees initially there will be there. So if there is a phase difference of 180 degrees, there should be a corresponding path difference also initially, that is lambda by 2. So now examining this particular thing, so these are the certain options for this one. Now we need to identify the path difference traveled by this one, that is delta x. So what is the extra path that has been traveled by the ACO to reach to the point P than the other light ray BP? So the extra path traveled by this one is going to be the C2O plus PO. So we can identify the PO value. Now I am taking this particular thing. This is the point O and here is the point P. Distance between both the things is going to be the D he has given here, and this will be your angle theta. From this one you can obtain that cos theta is equal to small d by PO. So from this one PO value will be equal to, this is d by cos theta, and this can be written as an d secant theta. That's what here is there. So PO value is being given. Now CO value also similarly can be obtained in the same way. This is a total angle will be here 2 theta. It is forming a right angle triangle again. So from this right angle triangle you can obtain the CO value as a PO cos 2 theta. Now equating it to the total path difference between the two light rays is, this is the one we have calculated here. So in this condition, so equate it to the path difference here. There is an initial path difference also is there, that is pi, due to the reflected light ray as we have discussed. On substituting this particular relation instead of this one, please don't. This is the one mistake that you are going to be generally conducting. Because it is an constructive interference, what we do general mistake is, for the constructive interference we go for the n lambda as a path difference. So please don't commit this particular, in this case it is a reflected wave, sir. So it should be the 2n minus 1 into, this is lambda by 2 due to this extra phase difference of pi. Now you can take the n value as a 1. So for n value is equal to 1, it will be the lambda by 2. For n value is equal to 2, it will be the 3 lambda by 2, as you can see here, lambda by 2, 3 lambda by 2. So this is the case, d secant theta into equate it to the lambda by 2 and find out the corresponding value of the cos theta, for which you will be getting the required constructive interference. So this is the one mistake, you please don't do this one. In this case, this n lambda is the formula for the constructive interference for the straight waves, not for the reflected waves. Please be careful of this particular point. Don't equate it to n lambda. It should be equated to the 2n minus 1 into lambda by 2. So please be careful of this one. So as we have done, equated this one, the total path difference, that is d secant theta of 1 plus cos 2 theta into, you can equate it to the lambda by 2 or 3 lambda by 2, you will be getting the further wavelength, that's it. So angle will be changed. So from this one, solving, you will be getting the cos theta is equal to lambda by 4d. So at this particular angle, or as he asked, theta is equal to cos inverse of, everybody can write this particular thing, lambda by 4d. So at this particular angle, you can get the constructive interference for the given condition or for the given reflected wave.